All right, good day. All right, so we are all ready to go with our titration to test for conductivity. And I have the computer all plugged in, so all the probes are hooked up and ready to go. So we're ready just to actually start assembling things. So I'm using one of these rods down in the back of a hot plate stirring sensor. They're in our cabinet. Just crank down this relatively tight. Most of these have little knobs here to get hold of. This one, the knob broke off, so I just want to get it a little bit firm. And the 250 milliliter beaker that we're going to use for the titration, I'm putting that on first. Now I went ahead and cleaned it, and I got a magnetic stirrer in there. And the biggest reason I'm doing the magnetic stirrer is so I can actually get my probe in there well. And I'm just going to set that so the steering rod is slightly off center. And now I'm going to put our conductivity probe in there. And I am actually just going to go ahead and pre-put it into this clamp. And I'm going to clamp it up near the top with this wing nut clamp. And then I'm going to put the cord so it sits on top here. And now I'm just going to position this so the probe is pretty much touching the bottom, but not anywhere near that magnetic stirrer. And then I clamp all that stuff relatively tight. Those two can't move. I need to raise my probe a bit. And we should be good to go on that. Now, I've already rinsed off this probe and I cleaned out that beaker, but make sure you do that before you go in there. So the probe is essentially ready to go. So I'm going to fire up the computer just to make sure it's working. So I'm running Logger Pro. And should pop up and we should see the little conductivity probe with the blue box popping up right away, and it did. So I'm going to go ahead and load up the program we're using today, which is under Advanced Chemistry, and it's 16A. And as long as it's going fine, we should pop up something down there. It's going to read useless information right now because I don't have anything in there. Alright, next thing I'm going to do is actually get the barium hydroxide in here, the stuff we're actually going to compare it with. And the directions say about 10 milliliters or 25. I'm using 10 today. So I need to get a small beaker for that. Let me use this 50. And I'm just going to put some of our barium hydroxide in. Got it sitting over here off camera. Now, I plan on doing 2 trials, well 3 altogether. So I went ahead and grabbed about 30 milliliters of it. I'll need to actually get more at the end, but I'm going to just make sure I just get just enough so I don't have any extra. And I'll show you what we're going to do with the extra when we're all done. And I'm going to do it with this run too. Alright, so I'm going to pull up more than 10 milliliters this time and then just let it drain out. Now I'm going to pull it up and get the 10 milliliters. Just going to go above the line with this pipette and then lower it ever so slightly. And right at 10. Alright, and now I'm just putting that straight in here. Now, this is not going to be enough to get that probe to start reading anything. 10 milliliters in a 250 milliliter beaker, it's just not enough. So what I'm going to do now is, and this part will vary some, since we don't necessarily care too much about the true concentration on this because we're going to actually mess with it anyway. I actually can just put some straight distilled water in here. So I'm just going to put some in until I see a reading on my probe. And I'm going to confirm, yeah, I just splashed on there. What I want is I'm going to visibly see that my probe gets some liquid on it. Okay. I almost put 100 milliliters in there. But you can see on your screen there, we got a conductivity of 1300s. All right, so we have conductivity there. All right, now, what we're going to do in this lab is we're going to add some sodium hydroxide, which precipitates out barium sulfate, and we should see the conductivity drop. So I got to get this on here so I can actually have my burette in there. But right now, the only thing I got, I just rinsed this burette. It's not ready to go. So I'm going to spin this off to the side some, and I'm going to put the, actually I guess I'm going to do it in the back, because I'm going to fill this probe. I don't want any of the stuff I put in there to actually get accidentally spilled into my test run. So I just got a waste beaker here, and I'm just going to grab 50 milliliters of the sulfuric acid. Alright, I'm going to put a funnel right over there. I'm not putting too much in this time, just going to put a little bit in. Because I'm going to use that to coat the sides of my burette. And I just drain out that excess. Get another bread. Hang on a second. Yeah, I got a bad one. Must have clogged when I actually got it cleaned up. But I was ready for that. I have another one mostly ready to go. So doing that same thing again, just going to put a little bit in here. Make sure the sides get coated. And drain out some of that. I'm actually going to drain it till it's below the 50, but not empty. And then put the rest of the sodium or the sulfuric acid I got in there. So I won't even bother to fill it. It's just going to be close. Before I do anything, I'm just going to, before I titrate that is, I'm just going to actually let some of this out so it's at a nice, good starting number right on a milliliter mark. So I'm starting at 18 milliliters on this burette. Alright, now, I spin it over here, bring it to this other side, make a minor adjustment to this so it's in a good position, and then I'm going to lower this down. So the tip is below the lip of the beaker, but I have good ability to grab hold of it. All right, now I'm over here on the computer. I'm just going to hit collect. And I'm and immediately hit keep and say that this is when nothing's been added, so 0 milliliters. And now all I'm going to do this first run is add a milliliter at a time until I see that change gets lower than like 100, or to the reading gets lower than 100. I'm going to wait until that stabilizes. Some probes will do this a little bit faster than others. Alright, I'm good with we're out there. It's still dropping some, but it's not dropping at a super fast rate, and I know it's going to keep on dropping. So I'm going to hit keep and say that was after I've added 1 milliliter. I'm going to do that again. This first time through, I'm just going to keep doing this 1 milliliter, 1 milliliter, 1 milliliter until I get that well under 100, and then I'll slow it down. But I'm not terribly worried about getting great results this time. This time I just want to know about what amount is where the endpoint is approximately. In the next run, I'll actually slow it down when I get close to that point and do drop by drop to measure the actual conductivity of each drop. Keeping there, we're right at 2 milliliters. Do another milliliter. Alright, we're getting close. You see how the conductivity is down to like 120? I do know this probe doesn't reach 0. I checked that ahead of time. I just put some straight of our distilled water in there, and it doesn't go quite to 0. But I'm going to intentionally on this one go past where I would actually do drop by drop, because right now it's probably a good safe bet to start doing like 1/10 of a milliliter, because you want to get it as close to 0 as possible. That's relatively stopped. We're right at 3 milliliters added. And do another whole milliliter. Good. All right. So see how it's shooting back up? It's well over what it was at just 2 milliliters in. So we've passed the equivalence point on this run. All right. So what that means is, and I hit keep here because this is our sacrificial run. These numbers are useless. But from this and seeing how it was going, we know that equivalence point is somewhere between 2 and 4 milliliters. So what I'm going to do this next run is at the 2 milliliter mark. Once I got just the 2 milliliters in there, I'm going to start doing tenths. And I want to get it to that point where I can say for sure the change happens between this tenth and this tenth. So it's going to be around 3 point something. But I want to get the exact tenth of a milliliter to see that change. And then the next time, I'm going to try to get even finer than that, even with drop by drop, and see if we can measure like half of this. But we're going to get a lot more precise the next time, and we should see that data. And seeing this, I have a suspicion I made my barium hydroxide a little bit less concentrated. So I'm not going to do anything about it. We're just going to have a quicker time doing this lab. All right, I'll cut to the data when I get both the other 2 runs done. Oh, something else I was going to say. When we're all done, any leftover sulfuric acid or any leftover barium hydroxide you have, just go ahead and I'm just going to pretend like I poured it out here. Pour it out into your stock solution and drain this in. Just make sure there's a lot more sulfuric acid in there than the barium hydroxide. All the barium will precipitate out as barium sulfate. And what we're going to do is there's going to be a beaker in the fume hood, and you're just going to pour this into it. And on that beaker is going to be like a coffee filter, which is going to collect all that solid, and I will dispose of the solid. The barium sulfate can go to landfill. I just need to actually make it relatively safe beforehand. Now, if any does get rinsed into the sink, it's not going to be a big deal. This is now safe for the most part. But we can tell it's done and precipitated because if you look at the screen, you see that conductivity shooting up like crazy. That is telling me that there's way more sulfates in there than there is bariums, and so the barium is now safely disposed of. I'm going to stop that because I don't want to have to rebuild this burette on the next ones. But just let it drain out and then rinse it with some water. Let those rinsings go in there, and then you can put all this stuff up. And then this is the only thing